first thing that might be misleading or maybe, I don't know, intriguing, the actual title of this talk, like to see a world in a grain of sand. This is an introductory line for the piece of poetry by William Blake. Very nice one. If you never read it, please read. But more or less, it's reverberate with my ideas. The ideas I want to share with you today. And first of all, I need to introduce myself because it's hard to follow the guy who you don't know who is, right? So I'm a professor in Elias State University, that's true. My main qualification is particle physics. PhD I had in theory. However, I work for, I think already like almost 10 years, maybe 9, but more or less like decade. I work on Atlas experiment at CERN, which is Large Hadron Collider, maybe you know. And I will try to give you my view on this challenge from the perspective of the scientist who works both in theory and in experiment. So, first of all, what is Atlas? Just to give you a brief intro to area of my expertise, right? Because some of you maybe will receive the mentorship from me. So what you might expect from me. So apart from the theory of physics, which will be applicable for any problem, but not directly, so this expertise might be a complete waste of time to mention. However, the Atlas experiment gives me the area of expertise which is more related to the electronics, signal processing, and so on. So this is a huge experiment. This is a setup built around the accelerator machine. And just to give you an example of the scale of this experiment, so these small things here, like you might see, right? Those are actually the people, like average people in a scale. So it's a huge experiment, lots of electronics, and it's custom-built electronics. And you need to process this somehow just to figure out what's going on inside this small part, like here. And all this electronics, it's separated on very, very large number of like parts. But I was working on tight calorimeter, and my actual task was data quality checking, error pattern matching, like introducing some error patterns as well, building the reconstruction algorithms, like rather testing them on simulations, testing them with real data. So I'm more or less aware of how to work with unpredictable data and what will be at least the general steps in order to process that. So that's the thing. And just to give you the more broader overview of what this Atlas experiment is about, it's about searching the particles. So maybe you're aware that there is a Large Hadron Collider, the LHC. It's at CERN. CERN is like Center European of Nuclear Research. The CERN abbreviation will not help you because it's like old one, which sounds cool, but the new one is more like it's European Center of Nuclear Research. And they built the 27-kilometer tunnel and built several experiments around it, and they colliding the bunch of particles, and it's always the frontier of the elementary particles, electronics, radiation sustained electronics, and also the superconductive magnets, and lots of interesting stuff going on there. But my main points of the talk will be not about me, not about Sam, not about Atlas. It's about the most important two inventions, which I think they are most important. I encourage you to say, like, what is your ideas, like what might be the two most important inventions from my perspective. I don't know, what is two inventions from your perspective, like two most important things. You might dump it in chat if you want, or you might ask me, like say directly if you are not muted. I hope you are not muted. So, do you have any idea? Do anyone wants to intervene? Come on, no one. Okay. Okay, so the interactive lecture will not be the case this time. So two most important experiments from my perspective, well, not experiments, but inventions of humankind, which separates us from the everything we had before. So the prehistoric people, like middle-aged people, I don't, ancient Greeks, like apart from the fire and like bowl and such a stuff, which we cannot trace in the millennia, there are two like most important things. The first one is the actual printing. The printing of books was a revolution because it's make the information cheaper, more robust, quickly rebuildable. And if, for example, Alexandria Library died in fires, and like completely eliminate all our knowledge about ancient people and ancient technologies. So now we feel more safe now because we can print thousands of books, not one or two like made by hands, but we are able now to print a lot of stuff, and the internet also is part of that. So, so I might say that printing is the great invention. However, inventing the internet is kind of followed to this step. It's just digitize the thing which we come up with. So how to make information and storing information cheaper, how to multiply it on separate sources and get some redundancy. And the second thing I want to mention, which might be also, it's kind of with us, but it might elude our attention. It's a scientific method. And this scientific method is actually a pretty recent invention. So I would say that it's more or less the same time. So 1 century maybe. So scientific method is something which separates us from ancient Greeks. So ancient Greeks, great philosophy, great ideas, amazing mathematicians. The same with Egyptians, Sumerians were great mathematicians as well. But no printing books, printed books, which means like the information was not stored. And even if it's stored, for example, Greeks' points of view, like Greeks' understanding of universe, was deformed towards the ideas. And sometimes we forget about this, especially if the discussion gets political. But the things in ideas, the bad thing in ideas, there are good things in ideas. Like, ideas are amazing because ideas could live without any particular realistic source of something. It's just in the mind. It's just our thoughts which makes the ideas real, right? But scientific method brings us the clarity, because idea might be completely cut it off the reality. It might be completely isolated. It might be not real, even harmful, and you might not understand it because it's in your thoughts experiments. Everything is fine. But it's kind of not working. There are several ideas. I will not make this topic, this talk like concentrated on religious or politics, because this is the areas the ideas are kind of might still survive isolated. But science gives us the only perspective, and only method which is sustainable with the universe. So we have ideas, of course, but this scheme is not, maybe not quite good representation, but it's common representation of science, and it's good enough to talk about it. So first things you start is to observe things. Then you start to research the area. So you might think, and then you give a birth for the idea. Then you made the hypothesis. So lots of us actually say that this is a theory. I have a theory of that. I have a theory. No, well, you have a hypothesis of something, and this is hypothesis before you check it. So the testing of your idea should be done for sure, and then it might become the working theory or something. But before this checking, you are nothing but philosopher or like ancient Greek guy or like guy who might live like thousands of years ago, because he do not have this understanding that ideas must be checked. And the testing of ideas is performed by experiment. And here we have a breakthrough. So first, that we need to check the idea. This is not like something I come up with. I come up with idea, but I need to check it for sure. And the second thing is the method I'm testing the idea should be as objective as it possibly could be. So this is the most important part probably. The idea should be checked with sustainable way. And after that you analyze the data, and the mathematics comes, and like data science and a lot of interesting topics might emerge from this. But the main reason is that like you need to check your idea. Like you need to check it with like most objective thing. And it's the same in science. If you want to work with scientific methods, if you want to make your product or more like, I don't know, your research or your piece of art, like more scientific, you need to check your ideas. And you're checking it not with other people, but with the universe, with the world, with the rule. Is your ideas compatible with the rules of the universe? That's what you need to check. And after that, you analyze the data, and then you kind of make the conclusion. And that's what we actually call scientific method. So now, big introductory, big consultation of this, and now some ideas from my field. Some not ideas, maybe inspirational ideas, maybe just information from my field. So my field of particle physics. My grandmom once asked me, like, what are you researching or what are you studying? And I say, like, by that time I was learning the electromagnetic field theory, which means basically I was learning how to describe the electron, you know, the small particle which just goes around the nucleus and which builds the atom, right? And my grandma started to laugh and say, like, oh, you are just crazy guy. Like, you try to search or research or investigate something that you cannot see. And that was kind of teasing perspective. Of course, she was not so naive. She knows that electrons exist. But there's something in this phrase. So we are now in areas which we cannot check by our bare eyes. So viruses, microbes, particle physics, you cannot check them. So only thing that people had like 50 or 40 or even 30 years ago was this kind of tracks. So this is the pictures of the particles. So usually what's happened, like you have like special tape. In this tape, the particle come in and destroy some materials during the path. And that's what's left, the tracks, only the paths that particle actually pass, right? And yeah, well, after that you analyze it, and still like the ideas I want to explicitly utter today is that it might look cool, like this is also like looks very cool, but it's not science. It's a game. The science has become the moment I started to check, analyze, and getting like what's inside these things. And I calculate, I recalculate, calibrate, analyze, and then it's getting like more science. And I am talking about like 50 minutes now, more or less. And now I might ask you a question, like probably you will not interfere with this voice again, but what was the reason of my exciting during the walk? And I've realized, I see the pavement just ordinary pavement, sidewalk road. And I see these tracks and I realize that, oh, this looks so much like a particle physics, right? There are tracks, there are some footprints, and they're imprinted accidentally. The most amazing thing on this. So even from the ordinary pavement, there are tons of information we just don't know how to get. But if accidentally we printed it, that gives us the idea. That gives the idea that even such a boring thing as a pavement might become interesting if you start study hard enough. My final one will be, I try to ask myself, what might be interesting, like what might be useful for you to hear from me in the context of this challenge. And I realized that probably the most important thing is you should realize that this content is not about winning. Well, it is, of course, you want to win, but the precious thing this content and any challenge and hackathon could give you, it gives you the environment. It gives you the special environment of connections. So you become connected with lecturers, with each other, with a lot of people who are connected with the same areas of interest, with different expertise, but with the same ideas of what interesting might be. And that's the precious thing. So please concentrate on this, even if you are the young student who just participate, don't choose even problem, thinks that, oh, well, this is not going to work. Don't drop it. Just try to bear it and try to know the new people, try to know the lecturers or like mentors or everyone, and try to feel yourself part of something bigger. So the thing is, it is really hard, especially in such a small country as Georgia. It's really easy to see yourself as a small part, a small piece, an incomplete piece, like lonely piece maybe even. So you might think that you are in Georgia. This is everything around you. What's matter probably, right? Some crazy political stuff going on, right? Nothing happened here, and I'm only one who are interested in these peculiar challenges or in some scientific topics. But that's not true, because right now you are part of something bigger, and you should realize that you might be, and I might be, the small pieces of something, but this something is a bigger world. So we are all just parts of bigger world, and everything, like since this realization, everything you start to do, please do it from the perspective of this broader view of the world, of the universe, because in the end, the frontier of mankind will move forward, and even locally, like here, we should accumulate, we should use the information which is outside. And the most exciting thing is that this works in both ways. So you might think that you're getting like more from the bigger challenges like this, but this bigger challenge is actually feeded on such a small part as we are right here, right in Tbilisi. And we might share some great ideas which will be unique from this tournament. So please think of yourself as a part of broad universe, and try to make these borders of like, what is this small pieces which are around you that you can change? What are this bigger picture? And what should be the interaction between you two? So that's more or less what I want to say today. I want to say special thanks to the FORSAT for giving me the opportunity to present this. And yeah, that's all. Thank you very much.
Thank you so much.